We're looking at the empirical rule today. Empirical rule is this right here. When you have distributions in the normal bell curve, normal distributions, right down the center here is where your mean is. So in this one, the mean is 60. And so most of your percent is going to be close to the mean, within 34%. And right here where this dotted line is, this is one standard deviation over. And then where this next dotted line is, there's another standard deviation. And here's another one, and here's another one. And then back this way, and so forth. Okay? And so what this rule says is that between 60 and 65, 34% of your population is going to be in there, or your sample. It's if it's a population or sample, either one. And then 13.5% will have scores between 65 and 70. And then between 70 and 75, only 2.35% are going to be there. And then 0.15% is going to be above 75, which is 1, 2, 3 over 3 standard deviations away. And then going the other way, it's identical, going the opposite direction. But like here you go, like what percent of scores is below 60? So like right here is 60, below 60, you're looking at 50% below 60. 50%. Number 2 here, what percents are between 50 and 70? So we're at 50, right here's 50 and 70. So we're going to add all these up right here. So it's going to be 95% between 50 and 70. What percent's between 65 and 70? Right here, 65 and 70, you're looking at 13.5%. What percent is greater than 65? All right, so we're right here, 65, so we're at 13.5, 2.35, and 0.15. That's going to be 16%. Number 5 here, what's between 70 and 75? That's 2.35. What's between 55 and 75? 55 is here and 75 is there, so we would add all these up right here, which is going to be 84%. And then what percent's below 70? Here's 70 right here. Below that would be 97.5, or let's see, 2.5, 97.5. Okay, so we're going to apply that to problems in statistics here. So like here's some questions here. All right, that's a little bit too big for the screen. I'll have to move it back and forth. It says, use the empirical rule. The mean speed of a sample of vehicles along a stretch of highway is 70 miles per hour with a standard deviation of 4 miles per hour. Estimate the percent of vehicles whose speeds are between 62 and 78. Okay, so what we're going to have to do is we're going to have to draw a bell curve. So let's do that right here real quick. And so right down the center here is our mean, which is 70. Our standard deviation is 4. So like right here, one over, we're going to have 74. Right here, we're going to have 78. Right here, we're going to have 82. Back this way, I'm subtracting 4, so it's going to be 66. This is going to be 62. And then this will be 58 right here. Okay? Now what we're wanting to find out is what percent is going to be between 62 and 78. So here's 62 right there. Here's 78 right there. Okay? Now the percents from the page we just had, this is 34 and 34. This is 13.5. This is 13.5. And so between those two, I would just add those percents up, which is, let's see, 68 and 27. That's 95%. There you go. See the answer right here. Okay. Number 2, this is not very difficult. I think you'll catch on pretty quick. The mean value of land and buildings per acre from a sample of farms is $1,400 with a standard deviation of $300. The data set has a bell-shaped distribution. Assume the number of farms in the sample is 76. All right, so let's draw this out. So we'll draw a little bell curve. So you have to draw this every time. Down here in the center is the mean, which it says up here is 1,400. So this is 1,400. This is our standard deviation is 300. So that means right here, this would be 1,700. When I add 300 again, and add 300 again. Okay, I go this way, I subtract 300. Okay, so there's what my distribution looks like. Okay, I didn't have it on the screen very good. I apologize for that. But there it is. Okay. Now the question says on here, the percent between 800 and 2,000. All right, so if I look here, 800 is right there, 2,000 is right there. So this is 34, 34, this is 13.5, 13.5, and this looks like, when I add those up, 95%. Okay, all right, now we've got this not finished because it says on here, use the empirical rule to estimate the number of farms. All right, this is the percent. Okay, get it on the screen here. We're struggling on keeping it on the screen. All right, so we've got 95%. Well, apparently there's 76 farms, so I'm going to multiply 95% times 76. So let's get my calculator in here. So 0.95 times 76, and it looks like 72.2. So this is actually 72 farms. Okay, and I think there's the answer right here. Now, B says, if 21 additional farms were sampled, about how many of those additional farms would you expect to have land and building between 800 and 2,000? So, of those 21, if I do 0.95 times 21, I'm going to get 19.95 or 20. So I would expect 20 of these new ones to be in that range. Okay? So it's not very complicated. I think you'll catch on pretty easy. Number 3 here. Okay. The mean value of land and buildings per acre from a sample of farms is 1,800 with a standard deviation of 300. The data set has a bell-shaped distribution. Using the empirical rule, determine which of the following farms whose land and building value per acre are given are unusual, more than 2 standard deviations from the mean. Are any of the data values very unusual, more than 3 standard deviations from the mean? So we have unusual. All right, unusual is 2 standard deviations. Then we have very unusual, which is 3 standard deviations. Okay. All right, so we're going to have to get us a bell curve here. So right down the center here is 1,800. That's our mean. All right, then our standard deviation is 300. All right, so if I add 300, that's 2,100. Add 300 again, 2,400. And then add 300 a third time, 2,700. Then I'll go back this way, subtract 300, so it's going to be 1,500, 1,200, and then 900. Okay? All right, so here's our values right there. Okay? So, unusual would be outside of 2 standard deviations. So from the center here, here's 2 standard deviations right here. So outside of these, less than 1,200 or more than 2,400. So this one's not in there. This one's $25.99. That's right here. We've got 1882. That's not in there. 807. Now here's one that's unusual. And then we've got 1221. That's right in here, so that's good. And then 16. So we have two that are unusual. So we've got $25.99 and 807. Those are unusual. Okay, because they're outside of 2 standard deviations. Now, which of the farms are very unusual, which means they're outside 3 standard deviations. And this 807, see, it's outside the third one. This one here is within the 3, so only that one, the 807, is considered very unusual. And you see our answers down here. So we're in good shape there. All right. All right, here's one. Scores of an IQ test have a bell-shaped distribution with a mean of 100 and a standard deviation of 18. All right, so we'll draw this out right here. I'll do it on the side here. Well, I'll come down here with it. That way I'll be on the screen good. So my mean is 100, okay? And the standard deviation is 18. All right, so this is 100 right here. One standard deviation would be 118. Another standard deviation, add 18 again. And then another one, 154. Okay, going back this way, I subtract 18, which is 82. Subtract 18 again, which would be, was it 64? No, hold on. 82, 18, yeah, 64. Okay, and then subtract 18 again, that's going to be 46. Okay. So part A says, what percent of people have an IQ score between 82 and 118? So 82 is right here, 118 is right there. This is 34%, and that's 34%. So that's 68%. Okay. Part B says what percent of people has an IQ score less than 64 or greater than 136. So less than 64 this way. Okay, let's put a percent in. This is 13.5. This is 2.35. This is 0.15. So if I add them two, that's going to be 2.5%. That's less than 64 or greater than 136. Over 136 over here, let's put this in, 2.35. This is also going to be 2.5%. So I add those two together, which makes me have 5%. Okay, so I have 5%, 2.5 that's below 64, and 2.5 that's above 136, and added together 5. Now part C here, what percentage of people has an IQ score greater than 136? Well, greater than 136 is the 2.5 we just did, so this is 2.5%. Okay. All right, let's go to this one here. This is number 7. If a variable has a distribution that's bell-shaped with a mean of 23 and a standard deviation of 5, then according to the empirical rule, 95% of the data will lie between which values? All right, so let's just draw this out real quick. The mean right here, it says 23. The standard deviation is 5. So if I add 5, that's 28. Add 5, that's 33. Add 5, 38. Subtract 5 going this way would be 18. Subtract 5 is 13. Subtract 5 is 8. Okay. So 95%. All right, if you, well, let me get it on there. This is 34. This is 13.5. And if you add these up right here, that's 95% right there. So it's between 13 and 33. So this is between 13 and 33. And you can see our answer right there, so we're in good shape. Let me do this one here, 12. The mean score of a competency test is 82, standard deviation of 2. Between what two values do about 99.7% of the values lie? Okay, so if I just draw my bell curve, and this is the mean right here is 82, and the standard deviation is 2, so this would be 84, this would be 86, this would be 88, going this way, 80, 78, 76, okay. So this is 34, this is 13.5, this is 2.35, 2.35, and I think that would put us at the 99.7%, because this is 0.15 out here, and this is 0.15, and if I add those two, that's going to be 0.3, which is 100 minus 0.3, 99.7. So it's between 76 and 88, and that's A. And you see the answer right here. Okay. So I think we'll go ahead and talk about Chebychevs. Chebychevs, I remember when I studied this in college, I always remember Chevy Chase. Chevy Chase. He was a popular comedian back in that day. And I think my instructor even told us about Chevy Chase. But this is Chebychev's inequality. And here's what it says. At least 1 minus 1 over k squared of data from a sample must fall within k standard deviations from the mean. Okay, so 1 minus 1 over k squared. What does that mean? Well, let's look at number 22, I think is where it starts talking about Chebychevs. So on 22 says, from a sample with n equals 24, the mean number of televisions per household is 2 with the standard deviation of 1. Using Chebychev's theorem, determine at least how many of the households have between 0 and 4 televisions. Now, if you write this out, okay, here's my bell curve. Right down the middle is the mean, which is 2. The standard deviation is 1, so this will be 3, this will be 4, and I have 5 here, and then back this way would be 1, and here's 0. Okay, we're not going to put the percents in this time, but what this is saying is, using Chebychev's theorem, which again is this right here, okay, determine at least how many of the households are between 0 and 4. So here's 0, and here's 4. So here's the mean right here. So we're looking at 2 within 2 standard deviations, which means k is 2 here. Okay, so I just do the formula, which is 1 minus 1 over k squared. So if I do 1 minus 1 over 2 squared, punch this in the calculator, I get 0.75. Okay, that's the percent, 75%. Okay, so if there's 24, all right, so I do 75% 24. So I just do a little multiplication here. 0.75 times 24, and I get 18. So that means there's 18, at least 18 of the households have between 0 and 4 televisions. That's what Chebychev is telling us. It says at least this many lie within k standard deviations. So since this is 2 standard deviations here, there's at least 18 of these 24 that have between 0 and 4 televisions. Okay. Figure 23 here. From a sample of n equals 36, the mean duration of a geyser's eruption is 3.13 minutes, and the standard deviation is 0.98 minutes. Using Chebyshev's theorem, determine at least how many of eruptions lasted between 1.17 and 5.09. All right, so if I draw this out again, and you could probably figure these numbers out without drawing it out. I'm just drawing it out so you can visually see what's going on here. But there's my mean, 3.13. All right, so, oh, I messed up on the calculator. 3.13 plus 0.98. I think it's going to be 4.08, yeah. So this is a, no, it's not. Yeah, 4.11. All right, so I'm adding my 0.98. So plus 0.98 again is 5.09. And there you go, there's 5.09. So that's 2 standard deviations over. So looks like K is 2. Let's just go this way and make sure that this number right here is that. So if I do 3.13 minus 0.98, I get 2.15. And then minus 0.98 again, and I get 1.17. That's right. Okay. So we're within 2 standard deviations of the mean here, each way, which means K is 2. And so what Chebychev's theorem says, 1 minus 1 over 2 squared is 0.75 again. So 75% of these are going to be between those 2 values. Okay? So if there's 36 of them, okay, I just take 0.75 times it by 36, and it looks like 27 of them. 27 of them are going to be between those 2 values. And that's what the answer is right there, 27. So that's how you can apply Chebyshev's theorem. Let's look at another one here. All right, this one here has several parts. We'll look at it, 25. I'm going to have to try to keep this on the screen for you. In December 2018, the average price of regular unleaded gasoline, excluding taxes in the United States, was 3.06. Assume that the standard deviation price per gallon is 0.4 cents, just 4 cents per gallon. Use Chebyshev's inequality to answer the following. All right, part A says, what minimum percentage of gasoline stations had prices within 4 standard deviations? Or we don't have to draw the bell curve out for this one because it's within 4 standard deviations, which means K is 4. So what I'm going to do for that, I'm going to do 1 minus 1 over 4 squared. Okay, so 1 minus 1 divided by 4 squared is 93.75. So 93.75. Now remember, this is a decimal here. Okay, and I got to change it to percent, which means I move it over 2. And there's the percent right there. And I'm good because here's the answer down here, see? Okay. Part B. At least, oh, I'm sorry, part B up here. What minimum percent of gasoline stations had prices within 2.5 standard deviations of the mean? All right, we don't have to draw it out because K in this one is 2.5. All right, so I'm going to do 1 minus 1 over 2.5 squared. All right, so 1 minus 1 divided by 2.5 squared. Okay, I don't know if you can see it on the screen there. And that's going to be 84%. So at least, now this is at least, it means it could be more. It could be 90%, but at least 84%, at least 84% of the gasoline stations had prices within 2.5 standard deviations of the mean. Now you could draw out your bell curve and figure out what these prices are. Well, we didn't have to though to figure out the answer to this, but now it's asking us here. It's asking us here. But now, what you can do, you can just do this. Since it's 2.5 standard deviations, because the empirical rule, when you draw the bell curve, it doesn't do 0.5s. But what we can do is this, 2.5 times 0.04. This is our standard deviation here. Okay? So if I multiply that out, okay, 2.5 times 0.04, I get this right here, 10 cents. Okay? So that means to be 2.5 standard deviations, that means I'm going to plus 10 cents and I'm going to minus 10 cents from the mean. Since the mean is $3.06, okay? So if I do 3.06 plus 10 cents, I get 3.16. If I do 3.06 and I minus 10 cents, I get 2.96. And so these are the numbers it's asking. The gasoline prices that are within 2.5 standard deviations of the mean are $2.96 and 3.16. Here, let's see we got these right, because here's the answers down here. All right, now this part C here says blank percent. Well, let's look at the question up here. What is the minimum percentage of gasoline stations that had prices between $2.94 and $3.18? Okay, well, we might need to draw our bill curve out for that one. So let me just do it right here. Okay, so right down the center here is 3.06. One standard deviation, remember it's 4 cents, so this is going to be 3.10. This is going to be 3.14, and another one would be 3.18. And there's the high value it's asking for. Now I'm going to subtract 4 cents, so this is going to be 3.02. Subtract 4 cents, it's going to be 2.98. Subtract 4, it's going to be 2.94. And that's the low one it's asking. So see, it's asking between these two right here. All right, so we're looking from the mean here. From the mean here, we're 3 standard deviations each way. So it means K is 3. All right, so according to this then, down here, if I do 1 minus 1 over 3 squared, okay, I'm just going to punch it in here. That's 0.888 repeating, which is going to be 88.89%. Round to 2 decimal places in the percent. So it's 88.89%. And you can see we got that right down here. All right, so that's Chebyshev's, along with the empirical rule. And that's it for this lesson. If you have any questions, just give me a shout, okay? Have a good rest of the day. Bye-bye.